Okay, so we're going to do a little bit more notes on this factoring because there's a lot of crazy factoring going on too. So I call this part crazy factoring. It's not just the typical quadratic things and stuff. So here's some different kinds of craziness. So difference of squares. So it has to be perfect square roots with a minus in between, right? So let's say like x squared minus 49. Now that's a perfect x square, perfect square root and perfect square root. If I perfect square and square, right? So we have x and 7, x and 7. One has to be plus and one has to be minus, and that's called a difference of squares. So let's do this: x squared minus 25, right? So isn't that an easy one too? X and 5, with 1 plus, 1 minus, and we're set to go. We could make this easy, right? So let's do x squared minus 144. Now that's pretty simple again. X and 12, 1 plus, 1 minus, and we have it done. But what happens if I was to make it a little crazy, right? So what happens if I said x to the 4th minus 36y squared? Right? So that's a little bit more crazy, isn't it? So this is a perfect square root still. So x squared here, and then this one would be 6y, and then a perfect x squared and a 6y, one's plus, one's minus. Make sense? Now, before I get to, I don't have enough room here, so one more that's even more crazy, right? So we're going to do this. It's a simple little x squared and a 81, right? So just by doing that, it's an easy one, right? So x and 9, one's plus, one's minus. All done, right? Well, oh, I should have done this one beforehand. Make this a 4, my bad. Make that a 4, and then make this an x squared and x squared, and then now do you see something? This one has a plus, so you can't do anything with that, but this is a minus again, a perfect square with minus. So if I had to simplify it a little bit more, so x squared plus 9 is the one that comes down, but then this one becomes an x and a 3, 1 plus, 1 minus, and now it's fully factored. So difference of squares is a good one for craziness. All right, so what about my next craziness? It's called take it out. So you can't factor stuff with an X factor or my friend's rock like my previous video unless you take out what's in common first. So I'm looking at this one here, and it looks like a good problem that I would X factor and stuff, but do you notice that each one of those has something in common? So in this case, I need to divide by 2 everywhere. So I'm going to take out a 2 here, so that's why I call it take it out. I take out a 2, so I'm left with 2 and then 3x squared. Take out a 2 this one, 8x, and take out a 2 this one, plus 4. And now I can, my friends, rock this or multiply, factor, reduce. Let's find out if it works. So I have a multiply with a 12, and then bring down the b, the bottom, the basement, so I've multiplied. Factored, so 12 is 1 times 12, 2 times 6, and 3 times 4. So 2 and 6 work. So 2 and 6, but that adds to positive 8, not negative 8. So I have to make them both negative. And I take my 3x minus 2 and my 3x minus 6. And I can't forget this 2 that I took out earlier. Now reduce is my last step, reduce by 3. So my final answer is 2 times 3 minus 2, and then x minus 2. So I had to take it out first, that 2. Now I can, my friends, rock this one from my previous video. Okay, so look at number 2 here. What can I take out? So I noticed that this is a 6, 9, and 27. And all of them have a 3 that you can take out. So take out 3 of 6, so that's going to be a 2x squared. Take out 3 of 9, so it's going to be a plus 3x. Take out 3 again, and you have a 9. Okay, now it's my friend's rocket. So 2 times negative 9 is negative 18. Plus 3 is the bottom, the b, the basement. And 18 is going to be 1 times 18, 2 times 9, 3 times 6, and that's it. So notice 3 and 6 is a difference. It makes it 3. So I have a 3 and a 6. Which one's plus and which one's minus? So one of them has to be minus because got to multiply by negative 18. And if I make this plus and that minus, that's 6 minus 3 is positive 3. So it looks like that's a good one. So I'm going to take this 2x, so 3. Got to remember this 3 that I took out earlier. 2x minus 3, and then 2x plus 6. And there's my reduced part. So I multiplied, I factored, and then the reduction is the one they have in common. So 3, 2x minus 3, and that becomes x plus 3 as my final answer. So you can multiply, factor, reduce, but you got to take out first. So that's my second craziness part. All right, my third craziness part, we are going to go into these cubics right here. So one is a minus, one is a plus. This first one has a minus sign, so it's cubic. It's a perfect cubic. The cube root of x cubed is x. The cube root of 27 is 3. So what we're going to do in our minds is we're going to cube root this first one. That makes it an x. We're going to cube root the 27 and makes it a 3. We're going to multiply, oh no, we have squared both of them. Let's see, we square both of them? No. We square the first one right here. Oh yeah, you square both of them. So it's going to be x squared, and then it's going to be 9 out there. And then you multiply those ones together to get 3x. So that's kind of how we get this little guy going. But with a minus sign, it's going to be minus plus plus. Minus plus plus. And we factored it. It's kind of a crazy little cubic. Here's the next one. We cube root this one, and we cube root that one. You square this one, x squared. You square this one, 9. And then you multiply this together, 3x. And this time it's going to be plus minus plus. And that is our cubics that are now factored. So kind of a crazy one there. Here's some more crazy notes continued. And this is our last little section of it. And we have a cubic again, but they're not perfect cubics and stuff. And this is going to be kind of like by parts, it's called. So I noticed that it's 2 times 9 is 18. 6 times 4 is 24. So when you notice that kind of thing, you can kind of gauge that it's factorable. So I'm going to take this section and these sections and take out what's in common. Do you see how they both have an x squared? And then what's left over? X minus 2. What do they both have right here? A negative 9. And then left over is an x minus 2 because you took out a negative 9 right there, right? So they both have an x minus 2 on it. So that's going to be my x minus 2 is taken out. I'm left with x squared minus 9. And actually that's factorable too from our difference of squares earlier. So x minus 2, and then an x and a 3, an x and a 3. One's plus, one's minus, and we have our final crazy factoring part. Again, this is going to be the section that we look at and the section we look at. So let's take out what's in common. They both have an x squared. So I take out an x squared and I'm left with x minus 6. They both have a 4, and I'm going to say take out a negative 4. And it's left with x minus 6 again. And you want it to have the same x minus 6s like that because I'm going to take it out. X minus 6, you take it out, you're left with an x squared and a minus 4. And oh my goodness, that's also a perfect difference of squares. So an x minus 6 is left over. And then this means x and a 2, x and a 2. One's plus, one's minus. And sure enough, we are done with that crazy factoring. So those are the notes for crazy factoring. Let's do some examples with the homework.